is no theories yet. We do not have theory. Or we do not have tools. Here, I give you an example. If you look at this, use the Euclidean space. You see A and B is A and B, AB. The distance between AB is less than AB is greater than the distance of AC. But if you look at those in the remaining distance, you will find that AB is less than AC. So big data space is a high dimension space. If we still use the low dimension ways to measure it, study it, obviously we have problems. Right? Well, you may say, okay, AI is so popular, then how about AI research? As you know that we in communication, so in October last year, I did a small project. I had to see the top 3 transactions of communication society. You see, for the early access papers, for example, the TON, right? The total number of papers in the early access stage was 30 papers. Only 2 are related with AI, or 6.7%. So the other journals, transactions on communications, transactions on wireless communications. So the early access papers, the percentage is, say, all around 5%. That means the AI used in communication research is around 5%. So it's very small. Let's back to the AI for privacy. So far, the only tool we for privacy is differential privacy. So people try to use differential privacy to new networks. You have different rounds of learning, right? So someone said, okay, in the last round, I insert noise using differential privacy to protect the privacy. Someone said, every round of learning, I insert noise to protect the privacy. All this, I think, is not the essential, not touch the essential of privacy. Now, a popular framework for AI privacy is the federated learning. But in the traditional way, if you want to do machine learning, so you collect all the data into the center, all the data in the same place, then you turn on your machines to do the machine learning. Of course, then if you put your medical data into the center, then the center may be curious. They may read your sensitive data. Okay, in federated learning, that says, okay, then your original data keep in your hospital, then you can only learning on your local place. You only upload the parameters of the learning to the center, and the center aggregate the parameters and then broadcast the new parameters for you to go through the next round. Then finally, we have a trained model. You can keep the data in your local place. So sort of privacy is protected. Currently, this is the best framework for big data privacy. However, there is a different vulnerabilities for federated learning. For example, I just give you a few examples. One is a poison attack. So when you do the federated learning, for example, you may want to know people's habit using the internet or using mobile. They may involve hundreds or thousands of people to hundreds or thousands of mobiles into the federated learning. someone said, okay, I'm a bad guy. I joined the learning. I try to mislead. I put the wrong data into your for your learning to mislead your conclusion. That's called a poison attack. So how do you know? There are thousands of users. How do you know some of them are malicious? And also, say if this user is Alice, this is Bob, or this is Chris. Chris cannot see the data of Alice, but Chris at the server side, Chris can see the parameters uploaded from Alice from time to time, every round, right? Then this bad guy can use a new technology called GAN, G-A-N, use GAN to recover Alice's data. That means the bad guy at the server side, based on the parameter uploaded to the server, he can recover Alice's data. That's the second, client data recovery. And also, we didn't mention the traditional attacks in the cyberspace. There's a lot of attacks, for example, distributed denial of service, information phishing, and so on, right? Some people are using neural cryptography. I'm not sure it's a new direction or not. Seems not that popular. So people try to combine cryptography with neural networks, but seems not that successful so far. So if at this moment, because we do not have theoretical tools, so when you want to have a reliable result, you do need depend on theoretical solution and the AI solution space. The result at the intersection is the reliable one. At the last section, I want to share some personal understanding about the future of the privacy research. I believe the most important tool is cryptography. If you look at the history of cryptography, at the beginning, they have symmetric encryption, right? That means you and me share the same key, then we can share a secret. Then they have the asymmetric key, sort of public key, then they have ABE, right? So a number of people, they can share the secret or in the cloud. That's the history of cryptography. But now in the big data privacy case, when we release a big data, we released the big data to a lot of people, right? So you see, the cryptography tools cannot meet our requirement. So when I have say health information, I want to release it, I will release it to any people, right? So I don't know who will share this information. So you cannot use the symmetric key or public key or even ABE. That means cryptography tool is not suitable for big data privacy protection. So that's my point is we need someone to improve or to invent a new encryption tool for big data privacy. That's my understanding. New tools, yes, we only have differential privacy. We do need new tools for big data privacy. Well, that's all from my talk. Thank you very much for your time and attention. And I would like to take some questions if you have. Thank you.
Thank you very much, Dr. Shu. We have a question from Dr. Muhammad Ashfaq Khan, and he is asking what kind of approach is best for imbalanced big data, especially in high-speed networks.
Can you repeat the question again?
Okay, so he is asking what kind of approach is best for imbalanced big data, especially in high-speed network.
Okay. Thank this. There are some based on my understanding. Yeah, please.
We can take his question directly. Maybe he's raising. Let me unmute him, and if Dr. Ishaq is available, then he can ask the question clearly. Maybe.
Yeah, offer me more information, please.
Yeah, more. Yeah, sure. So let me unmute him.
Thank you.
Sir, can you unmute Dr. Mahmood Ishaq? He is a participant in this event. Excuse me, Hamza.
Yes, I'm doing.
Yeah, please. Okay.
Okay.
Yeah. Yeah. So Ishaq is unmuted.
Hello. Hi.
Yes.
Hi. Thank you for adding me, and thank you very much for whole panel. My question is that someone we have the in high-speed network, especially in the intrusion detection system, we have the imbalanced data set. Especially we have the ICX 2012 and 2017, and few more ICX data set have the imbalance, and these kinds of data set have the large amount of data set, and how we can tackle the imbalanced data in intrusion detection, and which kind of approach is better for the big data to handle the imbalance problem in the big data.
Okay, thank you, Mohammed. Thank you for the question. If you look at my publication, I did work on the intrusion detection, especially for DDoS. Right? But 5 years ago, I pay more attention to privacy. What you mentioned may be related with the concept called deep inspection. So we have a we have a network. There is a lot of data, a lot of packets. How do we do the detection? I'm not sure what are people doing now at this stage. So maybe I suggest you to search the digital library to see what are the ways that people are doing about this. Or you send me an email about the more information. I need more details. Then I can give you some help. I may not. Okay, thank you.
So we have another question from Dr. Muhammad Noman. So Hamza, can you please unmute Dr. Noman? He can directly ask the question.
Yeah, yes, I am unmuting you. Dr. Naman, you are unmuted now. You can ask questions.
That was a good presentation regarding the privacy. My first question is that how does federated learning differ from distributed learning in data center environments? My second question was that why we need new tools. Just you discussed on the last slide that we need new tools for encryption or decryption in big data. So why we cannot use the existing tools that are available? These were my two questions. And regarding the previous question, we asked that in big data, if there is an imbalance problem, then how we can cater. So in my opinion, the data which is coming from heterogeneous resources is already imbalanced. For example, some sensor will be sending the data in sporadic nature. Some devices may be sending the data in different pattern. Okay, and some may be sending the data at a high data rate, at a low data rate. So you can see that the data is already imbalanced. Okay, so maybe this is my opinion. regarding the last question.
Okay, thank
That
you.
the big data, the data which is coming from different resources is already imbalanced.
Okay, thank
Okay,
you
thank you.
For the two questions. First of all, I welcome you guys to contact me to see if we can collaborate on some publication or maybe generate some good ideas. Okay, first of all. Second, I answer the question. For your first question, you say, what's the difference between federated learning and distributed learning? I think they are very similar. Maybe just different names, right? So people, well, a different group of people, they prefer use different names. Then they can claim that I'm the father of this. I think that's my answer for the first question. They are almost the same. Second question, you say why we need to invent new tools for big data privacy. The problem is the new big data privacy is a new thing, a new field. So the existing tools, you can use it, but not very. When you use it, it's not very comfortable. Right? You cannot use it smoothly. Sometimes not. Cannot fix the problem smoothly. So that's the reason we need new tools.
Thank you.
Thank you.
I think Dr. Ashfaq has another question, so maybe we can take this last question.
Okay.
Yeah. Dr. Ashfaq, Hamza, can you please unmute Dr. Ashfaq?
He can write to mute or unmute his mic. Meanwhile, I have unmuted him.
Okay,
He
thanks.
can ask.
So, Dr. Ashfaq, please ask your question.
Thank you again. My question is that can we use the few shot learning for the big data, and in the term of big data, we can handle big data with few shot, because in few shot we have some limited amount of samples, and then we train our system. And can we go with the few shot in big data?
Oh, thank you for this question, because I'm not sure. What do you mean field shot?
Few shot learning.
Okay. For this question, I'm not very sure, because we are also quite new to this AI security. So my group, we have 6 PhD students and some young faculty members. So
Right.
we are only a small part of it. But if we do welcome collaboration, so especially for Pakistani colleagues, right? So please email me, then let me figure it out. I also learn from you. Thank you.
Thank you.
Yeah, thank you very much for your insight.
Okay. Thank you, colleagues. Thank you very much. I'm very honored to have this opportunity to know you guys, and I welcome you guys to contact me, visit me either in Australia or in China. Thank you very much.
Yeah, thank you very much. Thank you for being with us. Thank you. Now our next talk is Dr. Amir Mahmood from Al-Khazmi Institute of Computer Science, UT Lahore. He will be delivering a talk on challenges of building Urdu language search engine using open source tools. He is an assistant professor at Al-Khazmi Institute of Computer Science and the head of high performance computing and networking lab for last 5 years, more than 5 years. He obtained his PhD degree in engineering from Department of Electrical Engineering and Computer Science from Technical University Berlin in 2012. And during his PhD, he interned with Dr. Walter Willinger, AT&T Research Lab at the Institute of Pure Mathematics, University of California, Los Angeles, USA in 2008 and 2011 respectively. So now let's welcome Dr. Amir Mahmood for his next talk. Dr. Amir, can you hear me?
Yes, yes, I can hear you. I'm just setting up my slides. Okay, so everybody can see my slides?
Yes, please continue.
Okay. So thank you very much, Dr. Walid, for the kind introduction. So today I'll be talking on challenges of building Urdu language search engine using open source tools. We have been working on this project for the last 5 years, and I will be talking in detail about how to use open source tools to build large complex systems. So agenda of today's talk is that first I will talk about some history of search engines, and then I will describe that what are the global trends and the market analysis for the search engine. It's a $1 billion industry. Then after that, I will briefly discuss the anatomy of search engines, and then I will go into detail about the challenges that we have faced during the development of Urdu search engine. There are some challenges regarding data collection and then data management and search management. And in the end, I will briefly discuss the future plan for a product. So as you know that the search web actually emerges around 1990, and the first kind of a search engine was ARCI query form. It was a searchable directory files, but there was no index present at that time. And the second generation was Wondex, World Wide Web Wanderer. And the first thing that the new thing was the web crawler. So the web crawler was introduced for the first time in this Wondex, and this was developed to measure the growth of the web. And then in December 1993, there was a new tool called Jump Station. So in that, the new thing was that the indexing and the search query system was integrated. So you can see that first we have ARCI. It was just a searching. You can just search files, and then we have a crawler. And then crawler afterward we have the first web crawler that was text-based, and it was used as the first full text-based search engine. And then, as you know, before Google, there were two major papers that came. One was on the PageRank, that was the PageRank patent, and in 1996 the rank text was used, and they were using PageRank patent, and then that actually paved the way for Google, and Google was offered in 1998. So as you can see, it's a very big market, and every one of us who are actually connected online, we rely on Google and other search engines to find the information that we need. So currently, as of today, as of August 2020, Google has a 92.05% of market share, and the second one is Bing, 2.83%, and Yahoo, 1.65%. And you can also see that there are some unknown names or relatively less known names for the general market. One is the Baidu and the Yandex and the DuckDuckGo. So they also have a significant market in the search business. So these are the global numbers. So if we see that regional search engines, so in the regional market, so for instance in China, so there are multiple search engines available, and Baidu is one of the leading Chinese search engine. It has a 77% market share, and the rest one, Sogu, Xinna, and the other one, they also have like some percentage of market share. Similarly, these search engines are, Google is not only the one search engine. In different countries, they have built their own search engines based on their national languages. So, for example, in Iran, they have a Persian language search engine called Use. In Japan, they have a Japanese search engine, Big Loop. And similarly, in Korean, we have a Dome. And in Iceland, we have Light. And in Russia, Rambler, Yandex. So in Bangladesh, we have Peptica. So there are efforts for developing regional search engines so that the regional content is and the search ecosystem can be developed. In general, search engine anatomy is like that. On one hand, you have a crawler. You need multiple crawlers to crawl the web. As you know, that the World Wide Web has a huge size. So that means that the crawler needs to visit every website after some month. And these crawler modules work independently, and they have different multiple requirements of compute resources and storages. And get data, and that data needs to be stored in some kind of repositories, which we call as a page repository. And based on this data, there are multiple databases are developed. So, for example, there is an index module where the data is indexed so that we can query that data, and then we have a content analysis so that we can do some kind of a metadata analysis. So, for example, if there is a web page, we want to know that how fresh that web page is and how many bytes are in there, which languages are there. So that is the information related to the metadata. So when as a user you query Google or any search engine, so what you do, you type in to your browser in your Chrome, or the query is then processed by the search engine, and then the data is requested to their data centers, and then they pull the data from the indexing. The results are shown back to the client. So this is a very high-level picture of the search engine, but there are lots of complex modules and softwares running on the background. So let's try to see that what are the main components that are required for a search engine. The first thing is that we need a data collection, and data collection is not an easy part. So you have to start from a point, and which what we call as initial seed preparation. And Bing, they use bots. So Google has a Google bot, Bing has a Bing bot, and there is an open source tool, Apache Notch, which can be used for crawling. And similarly, for once you have the data, then you need to manage the data. And for data management, we need some distributed databases like HBase, or we need some data indexing mechanism. And as you can see that there are multiple crawlers, they can bring multiple data from multiple sites, and that data, sometimes it happens that the one crawler and two crawlers bring the same data, and then the data is actually duplicated. So in the index, you need to make sure that the data is not stored duplicated. So you need some. And similarly, when you need to have a search, you need search management. So for example, if a user gives some queries, so you need to understand that what is the intent of the user, and then you need to respond back according to the requirement of the user. So ranking is a very complex thing, and Google and other search engines, this is their way of making money out of the search results. So let's see first the challenges in data collection. So for example, for a regional search engine, like for a search engine like us, first major challenge is we need to identify the natural language. So for example, if we have a document, we need to understand if the document is written in an English language, or if it is written in Urdu language, or Persian, or Arabic. So you need to look into every byte present on the web. So the first challenge is you have to actually search every web server to find the web page. And then the second step is you need to understand that if this web page is written in what language. This is a very compute intensive and time consuming process. And then The second thing is that once you have the data, then you can do some analytics on it, and then you can see if the web content is monolingual or multilingual, so that you can arrange those documents according to different language requirements. So for this first, what we did two things. First, we designed our crawler specifically for Urdu language, and we actually developed cloud infrastructure so that once we crawl data, we will store in that cloud infrastructure. And for this purpose, we started a very large-scale web crawling for Urdu content. The second challenge associated with this is that if we store all the data which is not Urdu related, then we need a huge storage. So just imagine that the scale of the Google. They have multiple data centers around the globe, and they need huge storage. So for our purpose, we were not interested in keeping the whole data, but we were interested in that we visit a web page, we see if it is Urdu or if it has some parts of Urdu. We will store only that data, and then the rest of the data we will discard. So for that purpose, we used the CLD2, Compact Language Detector 2 module, which is an open source tool, and it can detect up to 161 languages. So once we run, once the data is crawled, then we actually run the CLD2 module in it on the fly, and then we see that what percentages of different content languages are there. So for example, in this example, for the first line, we can see that the whole language is actually in Urdu. So the CLD2 has detected, okay, it has 91 bytes of Urdu, almost 98%, and the rest of them are punctuations. And the second line, what you can see is that we have 81% Urdu, and then we have 17% English. And in the third example, we can see we have 51% of the bytes in Urdu, and then 37 in Persian, and 10 in English. So it can detect all these things. So we use this language ID tool, and then based on these observations, we develop our own language ID tool, and then we run both language ID tools to see that when we detect Urdu language content. With Urdu, there is a problem that it has the overlap with Persian and Pashto and similar languages which are written in similar style. So we actually had to optimize our language ID module so that it has more performance over the CLD2, because in CLD2 what we have observed was that they were mixing up Persian and Urdu. So we developed our own language ID module to avoid that problem. So for the seed preparation, whenever you have to start, whenever you need to build a search engine, you need to start, and the starting point is seed preparation. And for the seed preparation, what we did, we analyzed 200 plus terabytes of uncompressed data. These were like 2.87 billion web documents provided by a common crawl corpus. We took their 2016 snapshot, and we analyzed their data using different Amazon Web Services, EC2, Elastic MapReduce, and S3. And based on that data, we extracted domains, Urdu domains. So based on those results, what we can see here is that there was, what we found for the regional languages, there were top 8 languages were contributing like 7.26%, and there were different Chinese versions. And then what we found, the Urdu and Hindi has a very small share in the global share of content. And from the multilingual perspective, we saw a difference. What we found was that in the common crawl corpus, there was 60% of the web pages in which the only language was English. So they were exclusively English pages, the single language pages, and the rest were multilingual. And similarly, we have this distribution for other languages. What we were interested in was that as far as Asian languages are concerned, they are not, there are very few percentage of pages shown in these red color that was single languages. So most of the pages that we observed in case of Asian language they were multilingual. So for example, if there is an Urdu page, there is also an English page associated with that one. Or if there is an Urdu page, then there is also Arabic page associated with that one. So we found that in case of English, it's easy that since most of the content is only in the English, but in case of Urdu, we have to identify other languages as well. So we started with 500 unique domains that we selected from Common Crawl, and we use Apache Match 2.4 for this large-scale crawling. And we did crawling for like 2 to 3 years. And then in that, what we found was that in once we are running, these crawlers are running 24/7. So they have to run all the time. So what happens when if there is a power failure, then whole crawler state is gone. So we implement features. So for example, for every particular, after some time, every few documents, we store a checkpoint state. So if the power failure occurs, then we can actually go back to that point, and then we can, we don't need to start right from the beginning, we will start just from the checkpoint. So for this purpose, we use Hadoop ecosystem tools like Apache Space and Apache Hive to query, and we deployed it on our cloud infrastructure. So one of the problems that we faced while content parsing was that whenever you have a content present on the web page, you also have some content present on the sidebar. So normally what we, as a web search engine, we are interested in the main content that is shown in the green. So that is shown in the, not in the green or red. The green and red is actually noise here. So what happens is that when you crawl, these noise also actually appears in the data. So you need to clean. So for that, we developed a web article miner algorithm using boilerpipe for Urdu content, which actually detects the noise in the data and then cleans the data. Why we are interested in doing this cleaning is that once this noise is present, it actually affects your ranking results, because user is interested in the main content. They're not interested in the side content. So once the content is present, so if you include that data in your main web content, then what happens that when the search results will be queried, you will get the wrong result. So in order to improve our ranking, we had to develop that content parsing algorithm. Secondly, in case of Urdu, there is a huge amount of data which is present in the form of images, and those images are not searchable. So for this, luckily we already had in our Center for Language Engineering, so they have developed optical character recognition, OCR for Urdu languages. So in this, what we happen, we get the images and then we can just convert them into text that is searchable. So we integrated this OCR into our search engine. So after getting the data with the crawlers, and we need to, the second challenge is we need to do some data management. So how do we store that data, and how do we actually index that data? So for this, we need to develop a real-time full text search, and we had to do some query formation and optimization in the search engine. Secondly, the duplicate documents need to be detected. The reason why we need to detect duplicate documents is that we want to have storage optimization. So if we store one document 2 times, obviously the storage requirement will be increased. And then the next thing what we want to do was that whenever we have a document, we would like to see that if it is a news document, if it is a blog document, if it is a religious document, so that the search results can be improved. So in general, data indexing is done using Apache Solr tool. So in the indexing is a process where what we do, we have, let's say we have multiple documents. In this case, what you can see, there is a document 1, document 2, and document 3. What we do, we first pre-process the data to remove the stop words. These are the most common words. They don't have much meaning, so we just remove them, and then we store the rest of the words. So for example, what you can see here is the best word is appearing in the document 2. Here we have an index that knows, okay, the document ID has 1 word, which is best, and it is present in the document 2. And similarly, we have this inverted index, which is prepared. It is a very compute-intensive process. So just imagine that if you have a huge data, this process will take multiple hours or even multiple days. So for the domain identification challenge, we need to organize documents according to the type of content. So in the major challenge in Urdu domain identification was that there is a scarcity of high quality labeled data set. So for example, if you need to identify that if this is a document related to sports, then you need to, for the machine learning algorithm, or you need to have a labeled data set. So for this purpose, we build. Another challenge is you don't have any classification models, and any processing method and text feature extraction techniques are not present for Urdu language content. So for this, we actually developed a machine learning algorithm to categorize a page into 6 categories. And these 6 categories, they work like that. You have random documents coming into a machine learning classifier, and then the classifier based on the algorithm, based on our model, it actually classifies if this news is actually sports related, or if this news is health related, or if this news is technology related. So, and we have been using these domain identification in our search engine. We have different sections in our search engine, like health, science and technology, and entertainment. So we identify these documents and then we present in real time. So any document, if let's say if there is a news coming in, right now we will, on the fly, we will classify it and then we will put it into that particular section. So next challenge is related to the search management. So for example, whenever you visit or whenever you want to search, you need to give input to the search engine. So in our case, the first input is the through keyboard, or you can write it in Urdu language. And the second, what we have done is that you can also do input through speech. So then in case of speech, so we have different challenges in case of text, and we have different challenges in case of speech. So Urdu have more alphabets than English, and Urdu is also a complex language that once you write, the writing is not simple. So you have to make sure that there are no extra spaces. So if there is an extra space, the word can actually have a different meaning. Similarly, in case of speech, there are different accents that exist in Pakistan. So, for example, if you are in one region, people say the same thing. If you go to another area, they will say. The challenge is to identify and handle those accent variations. And similarly, in the search ranking results, as I mentioned in my earlier part of the talk, was that the Google was based on page rank. But if you apply Google page rank or page rank on Urdu websites, it calculate, because as Professor Shui mentioned that big data means big graph, and if the big graph is not connected and there are some edges missing, then you cannot actually compute the whole page rank. That doesn't mean anything. And similarly, another challenge in search management is the user behavior. So for example, all search engines or most of the search engines, what they do, they give personalized search. So if you are interested in something, if you're doing queries in more on one topic, then they actually use this information to show you ads and monetize that information, and also to give you more better results that you are interested in. And similarly, we can provide safe search for Urdu content. So for example, we have modules developed in so that we can detect profanity in the content or hate speech in the content, and then we can lower their ranks while showing the results. So this is what you can see. This is a speech to text system. This is a Hamkirat Pakistan set bar. What you can see here is that you can query that will go to the Hamkirat website, and then we have an independent system, Urdu's speech to text system. We will get the result back, and then once we have the text, then we can just pull the data, we will query our index, and then give the results to you. So there is you can also there's a bar, and you can test that yourself. So one of the challenges is the Urdu website ranking. The page rank failure for Urdu website I have already mentioned. It cannot be calculated due to Gaussian link graphs. And also, it has a problem that the values are sparse and cannot be normalized. The majority of websites, they do not have a good page rank. So we developed our own scoring algorithm using domain, quality of domain, and the quality of content for each website. What we call as the A rank. Here what you can see is that there are one challenge is that you can see that multiple sites can have a similar document. So this is like a famous column writer. It has his column is published on two links or two websites. They have their main publisher, but the websites are two different. So we need to make sure that we have one copy of that one. So before deduplication, you can see the content looks like this, and after deduplication, the content looks like this. So this is a major challenge that we have to face to get data deduplicated. So we deploy MD5 and text profile signatures to identify deduplication. And similarly, for search results ranking, we deploy BM25 ranking model for document selection, and we score for every website. We have calculated a score, and if we find like a profane document, we rank them negatively, and if we have recent documents, we boost them by giving some extra ranking points. And if we are also working on getting the quality of Urdu content. And if the quality of Urdu content, we are developing our own matrix to identify quality of content, Urdu content, and we rank them high. So for example, we have different dedicated sections available on Urdu search engine. It is a web, books, religion, news, poetry, sports and videos, Wikipedia, and famous sites. So you can visit Hamkina search engine on www.hamkina.pk, and then you can use all that one. So from the ranking point of view, what we do whenever we receive a query, we first do stop words. We remove the stop words, and then we use our retrieval model BM25. And then after getting the scores from the websites, we check the recency, and after that, if the document is profane, we just filter them out, and then we apply user-based ranking, and we do deduplication, and then we show the result. And we pull all these results based on our two repositories. One is the Hamkina index, and the second one is the web analytics repository, where we see that which web page is actually visited most, and if someone is interested in more, we can boost those based on our contact analysis. So this is the portal that we have. We have just shown you the Hamkina results for query Pakistan. You can see if you speak Pakistan or if you write Pakistan in Hamkina search bar, you see the results, and these results are based on all those problems that we have already solved and built into one system. So these are the publications that that came out of our work based on Hamkina search engine. So it's an ongoing effort. In future, we are using this platform. We are building a plagiarism detection system. So for example, for Higher Education Commission, whenever there is a thesis submitted to HEC, they don't have a mechanism to see plagiarism in Urdu language content. So now we have a Urdu search engine, and we have a repository of theses written in Urdu language and books. We can detect, based on this data, we can detect plagiarism if it is present in any new document. And then we are building a journal indexing system for Urdu research papers. So right now there is no journal indexing system present in Pakistan. So we started for all the journals. We started first for the Urdu language, but now we are extending it to the other Pakistani journals as well. And similarly, based on this data that we have, we are detecting fake news and propaganda present in the web documents. And finally, we are developing search as a service facility for e-governance and businesses. For example, if there is a web portal or any government search, and any government agency that they want search as a service, we can enable them on their website. So these are some of the ongoing work that we are doing based on Urdu search engine. So I would like to thank. These are all my slides. So if you have questions, so you can now ask.
Thank you very much, Dr. Amir, for giving us a very nice talk, very insightful information on search engines. We have a couple of questions. So let's start from Dr. Ishfaq first. Hamza, can you please unmute Dr. Ishfaq?
Dr. Ishfaq, you can ask questions. Thank you.
Right, thank you very much. Can you elaborate the diagram that use the Hamza search engine in text?
You mean this slide?
This.
Yeah. So what's the main question?
Yeah, I am confusing the website scoring and.
Please speak loudly. I cannot hear you.
I am confusing about the website scoring here. How can you differentiate and?
Also, you mean that how we see the website scores, right? Right. Okay. So for example, if you look at the let's take a general example. So if I use for any news, let's say I use BBC Urdu. This is one website. We have Dawn News, we have other sites, and then we have multiple Urdu websites. So what we have seen is that there are some Urdu websites, they are contributing more documents daily, and there are Urdu websites, they are just they are there, but they are not growing. So we check out these growing parameters, and we see that how much their growth is, and then we score them differently. Because if you are contributing more documents, you have more documents in our index. There is a more choice that you will be searched more. So we score according to their number of documents, we score according to the number of quality of content, and we score number of their domain rank itself. So did I answer the question?
Of visitor and on the basis of content quality.
Yeah, exactly. We see that for example, if there is a website which is very often visited, so we actually improve the rank, we increase the rank.
Right. Okay, getting you.
Okay, thank you very much. And next question is from Dr. Noman. So Hamza, please unmute Dr. Noman.
Thank you, Dr. Amir. That was a very nice talk. My first question is that you're talking about the removal of duplicate documents. So which document will be removed if they are from different sources? For example, from one news channel, from another news channel. Is one source may have a higher rank than another. Okay. And my second question is that if you are thinking about a page rank sort of algorithm, okay, then why you are removing the duplicate documents? Maybe in future the document on that page could be used in ranking the page. Thank you.
Right. So really very good question. So one thing is that what we have observed in Urdu, in case of Urdu, was that people actually they copy the content without the permission of the publisher. So, for example, people have. This is the case that we are saying. I'm showing you this. This is not that case. In this case, the publisher is same, but they wanted to have more audience. They have two websites, and they are trying to increase their audience by just putting it on two websites. So in this case, what we do is that we select one with the highest rank. So that is actually understandable. But the second case is more dangerous, in which that anybody actually can make a portal, and then they will just show you the similar news. So in that case, that content is actually not a legal thing. So we even the publisher, they don't want them to show their content there. So they claim.
But how we can ensure that in this case this is a problem from the publisher point of view? If we are talking about a situation where a lot of documents are being present different sources and we are crawling those documents. So we are not having concern like this, that for this document we have a publisher sort of concern and these documents are legal. We are just crawling all the documents. So how we will ensure all these things in this situation?
Right. So we don't. So there's a difference. That one is that the result that we show in our final results, and the second is that if the document is present in our rank index. So we do keep that index document in our index, but we rank them negatively. Do you see the point? So as far as the calculation is concerned, the document is there, but as far as the results presentation is concerned, the document is not there.
And in how this removal of the duplicate documents will affect the rank of the pages or different websites as well.
Can you repeat the question? I couldn't hear it properly.
Okay, for example, you are going to remove the duplicate documents from some authentic sources or from duplicate sources. So in future, this duplication sort of removal could affect the ranking of different pages. So why you are going to remove these documents? Why you are not keeping all the documents?
No, we are keeping those documents. We are not showing them. We are, if we detect duplicate, we rank them negative. We just lower their rank. We keep them, but we lower the rank. They will not appear in the search results, but they will be with us in our index.
Okay, thank you.
Okay, so we have another question. Mr. Muhammad Ahmed Abdul Rahman. Hamza, can you please unmute Abdul Rahman?
Yes, Muhammad Abdul Rahman. Muhammad Abdul Rahman. It's Muhammad Ahmed Abdul Rahman. You are muted now.
Yes, he is Muhammad Ahmed Abdul Rahman.
Sorry, sir. There was some technical issues with my network. I was unable to hear some part of the talk. So it was a good talk, very informative. Thanks.
Okay, thank you very much, Abdul Rahman. So that's it from today's talk. So thank you very much, all the speakers, that they have given very insightful talk to the participants. And I must thank all the participants for attending this workshop. And I also thank the organizers of this workshop, Mr. Kashif and Dr. Waqar Mahmood, for making it possible for today's event. Oh, thank you very much. Let's conclude this event now.
have Dr. Amjad from FAST with us, so if he can share the closing remarks. Dr. Amjad. Is there Dr. Amjad with us?